Hello students. So today I am going to discuss the conclusion of this dual nature of matter and radiation, and in this chapter the last part which is about division and Germer experiment. So once again, if you recall the previous classes, in previous class I was discussing about the study of this the wave nature of a matter, as well as we discussed about the wave nature of matter and the de Broglie's hypothesis for the wave nature of matter, and thereby we calculated the one mathematical equation that theoretically calculated by de Broglie, that is lambda is equal to 12.27 angstrom divided by, that is root V, where V is accelerating potential. So this is the wavelength associated with the material wave particles. For we can apply this equation for the material particles such as electrons. So this equation we found in our previous class, and we took about the de Broglie's hypothesis. And for the today's class, what I am going to discuss means, I am going to discuss about division and Germer experiment. So what is this experiment is mainly focusing on? So this division and Germer experiment is mainly focuses, or it will give the practical proof for de Broglie's theoretical hypothesis. According to the de Broglie, he said that every material particles, every moving particles of a matter are associated with wave, and that wave, they are associated with the wave, and that wavelength of the material particles can be obtained by using this generalized formula known as de Broglie wavelength formula, lambda is equal to h by mv, and this calculation he done theoretically, and this experimentally they have concluded and they have calculated. Suppose, so now if you consider the de Broglie's formula, if you consider de Broglie's wavelength formula, so now let us consider de Broglie's wavelength formula, lambda is equal to h by mv. Suppose if you calculate, so this is nothing but the what, h by mv, and we can apply this equation for material particle as well as for the wave, that is nothing but the for radiation. So we can apply, this is the generalized formula. It can also applicable for the particles of the radiation, even it can also be applicable for the what, material particles. Suppose if I take electron theoretically, so we know that the modified equation, when an electrons are accelerated to the certain potential, at the time the wavelength associated with the electron was calculated as, so that is lambda is equal to divided by root V. So this is wavelength. Suppose if I take this equation, suppose if I apply for electrons, so let us consider electron, consider an electron. Suppose if I accelerate that electron by applying a potential difference of 54 volt, then what is the value I am observing? Lambda is equal to, so I am going to observe that the lambda value will be 1.66 angstrom. So what I am going to observe, the value is 1.66 angstrom. Suppose if you substitute in place of this 54 volt with the help of theoretical formula proposed by de Broglie, suppose if you calculate wavelength associated with the electron, this is electron is nothing but the what, a material particle. Suppose if you calculate the wavelength associated with the electron, that will be given as 1.66 angstrom. Okay, the same value experimentally this was proved by the scientist, namely division and Germer. So therefore, for today's class we shall discuss about division and Germer experiment. Division and Germer experiment. So very important part it is. So in order to prove the, so what is the outcome of this experiment means, it is very, very important. Division and Germer experiment, they are mainly discovered, or they have gave the practical proof for wave nature of electrons. Experimentally they proved. This point is very important because in 1 mark this experimental detail is not there in the syllabus, but anyhow it is required for the what your studies. So it will be essential in order to have the proof of this wave nature of the electron, how experimentally they got the proof. So if I say theoretically de Broglie hypothesis about wave nature of electron means whether it is practically true or not. So that practical proof is there and it is given by these two persons. So therefore what is the main outcome of this experiment means wave nature of electrons. This is very important, wave nature of electrons. So please keep in mind. So in order to perform this experiment, they have used some experimental arrangement. I am going to show that experimental arrangement. So if possible, you note down all these details in your book. So or else just you can go through this concept. So here it consisting one filament and this filament is connected to a low tension power supply. And this filament is further connected to the what? A high tension power supply. Further it is connected to an high tension power supply. So I am showing here, just you can go through this. So we can also call this filament as, and this whole apparatus we call this one as, this filament with battery, it is called electron gun. Electron gun. Okay students, so this is about the experimental arrangement considered by Division and Germer in order to prove the wave nature of the electron. So what is the experimental arrangement is consisting means, the experimental arrangement is consisting of one electron gun. So that is filament, and that filament is subjected for the low tension power supply, and this filament is once again connected, this filament as well as this anode, a represent anode here. So generally this anode is nothing but the what? A cylindrical chamber provided with a small hole here. So along its axis there will be a one small hole, along its axis there is a one hole, and through this hole what happens, instead of entering the water, the bundle of instead of entering the electrons, so the collimated beam of electron is made, and this collimated beam was done by this anode. So instead of sending the electron rays, so here they made it as a one collimated beam. So beam means what? It is bundle of electrons. So bundle of electrons are made, and they made to concentrate on a one straight line. So bundle of electrons are concentrated on a one particular line. Alignment of electron will be done with the help of this anode, and remember remember this anode as well as this filament are subjected for high tension. HT means here high tension power supply. And what is the use of this high tension power supply means this high tension power supply will accelerate the electrons emitted from the filament. So here filament will produce electrons, it emits the electron, these electrons are accelerated with the help of high tension battery. And how it produces electron means due to the low tension battery here. And remember this high tension battery has got some variable values. So I can vary the accelerating potential for the electron. So I can vary for the desired values. So here what happens as the electrons are emitted, so with the help of this high tension power supply I am going to accelerate, and while accelerating I can concentrate the bundle of rays of electrons into one constant, that is a beam or one collimated beam, and that collimated beam was done with the help of this anode. And such collimated beam or electron beam is get incident on a nickel crystal here. So as this electron beam incident on the nickel crystal, what happens, thereby the electrons will collide with the the crystals, so nickel atoms, so atoms of the nickel inside this crystal. So thereby what happens, the electrons get scattered, and the scattered electron I have represented with the dotted line here. So this is nothing but incident electron beam, and this is nothing but the scattered electron beam here. And the scattered electron beam for different angle of scattering, so this is angle of scattering we call theta, I have represented here. So theta is called as angle of scattering. So this is very important here. So what is angle of scattering means? So it is the angle between the incident electron beam and the scattered electron beam, that is angle of scattering. I can listen here. So this I can weave the scattered electron with the help of this detector, and this detector will detect the scattered electrons for the different scattering angle. How I can get the different value of angle of scattering means with the help of this scale. So here there is one scale attached with this detector, and this detector further is connected to the galvanometer. Why it is connected to the galvanometer means, so the number of electrons scattered for the particular theta will be indicated with the help of this galvanometer. Galvanometer will indicate the intensity of the scattered electrons. So if there is a more number of electrons are get scattered per second means the deflection in the galvanometer will be more. So if there are least number of electrons get scattered means this detector in turn is connected to the galvanometer, and this shows some small deflection for the particular angle. So what is this? Whole this apparatus they have designed by Division and Germer in order to prove the wave nature of electron. So what it consisting? It consisting one electron gun. What is the function of this? It produces electrons due to this power supply, and these electrons are accelerated with the help of high tension power supply, which is connected between the filament and anode. What is this anode? This anode will makes the collimated, a very narrow beam of electron will be done by this anode by passing the electrons emitted from the filament. When you pass through this anode, they becomes a collimated beam or electron beam. Such beam will be incident on the nickel crystal, and thereby on the nickel crystal they get scattered. So thereby there is a collision of electron with the atoms of the nickel, thereby the electrons get scattered, and they get scattered into different directions. So we can also calculate the for a different angle. So we can calculate the intensity of the scattered electrons, and this intensity can be noted with the deflection of the galvanometer. Okay, so is it clear? And remember here, so this experiment they have repeated. So this experiment they have repeated for the by varying. They have recorded. Now they have studied the they started recording about the for various values of V, for various values of V. For various values. So it means they have varied this high tension power supply voltage here. So they have varied the high tension voltage or high tension power. So it means they made the electrons, they accelerated for different values of desired potential, for different values of desired potential, for different values of, for different values of V. So V, that is nothing but accelerating potential. So I am going to write it as, this is nothing but an accelerating potential. So please go through this. So what they have done, so electron gun is emitting the electrons, and these electrons are accelerated with the help of this high tension power supply, and high tension power supply is a purely variable. I can vary and I can set for various values of potential. Accelerating potential can be varied from desired values, say 40 volt, 50 volt, 55 volt, 60 volt, like that I can vary the value. And remember, such accelerated electrons are made to pass through the anode to make the collimated narrow beam of electrons. Such beam is made to incident on nickel crystal, thereby they get scattered, and these scattered electrons can be observed through the detector, electron detector we call. This detector is connected to the galvanometer. Why? Because for different angle of scattering, the intensity of the electron, this is very important, for different angle of scattering, the intensity of the scattered electron will be different, and that can be noted with the help of deflection of the galvanometer, because galvanometer is the device which is used to sense the current. That's all. It will not measure the current, but we can say that the deflection of the galvanometer is directly proportional to the current. If more current is there, so more will be the deflection. When more current will be there, if there are maximum number of electrons get scattered for particular angle theta, at the time galvanometer is showing some maximum deflection. So therefore, now what division and Germer did means, now they have varied this high tension power supply for different values of V, means they are varying this accelerating potential, and they are noticing about the what intensity of the scattered electrons for the corresponding to the different values of theta. And remember, so how they have varied, what is the value they are varied means, so now we shall go practical. What is the value they have considered means, so listen here, the practical value, so it means during their experiment they varied the value of V from 44 volt to 68 volt. So it means they are varying the accelerating potential between 44 volt to 68 volt. But what the observation they did means, therefore what the observation they did while accelerating from 44 volt to 68 volt means, when the accelerating potential was at 54 volt, when the accelerating potential is at 54 volt, they observed that there is a strong peak of intensity, and this strong peak of intensity of the electron corresponding to the, and it is corresponding to the, there is a strong peak of intensity of the electrons corresponding to the scattering angle, that is 50 degree. So they have observed this one. So what the observation they have did means, so they have observed that the scattering angle is for the scattering angle 54 voltage. At 54 voltage there is a strong peak of intensity of the electrons, and this is corresponding to the angle of scattering is, that is 55, that is a degree. So corresponding to the scattering angle 55 degree. So here what they have did means, they observed the what strong peak of intensity at 54 voltage and corresponding to the scattering angle theta 55 degree. Then according to the Bragg's law of diffraction, so according to the Bragg's law of diffraction, we have one condition here, that is 2d sin phi is equal to n lambda. And remember why they have used this equation means, so here at 54 voltage there will be a maximum strong peak of intensity of the scattered electron. So this will be because of the what constructive interference, and hence according to the Bragg's law of diffraction, if I want to calculate the wavelength of that scattered electrons, so then I am going to use one equation, that is according to the Bragg's law of diffraction. So this equation is proposed by the person Bragg's. Okay, so this is from Bragg's law of diffraction. So from Bragg's law of diffraction, so Bragg's law of diffraction, where D is called interplanar spacing of the nickel crystal. And remember, interplanar spacing, it is called interplanar spacing. And for nickel interplanar spacing For nickel, this is very important, 0.91 angstrom. And remember here, phi is called glancing angle. Phi is called as glancing angle. And remember, so this phi is called glancing angle, lambda is called wavelength. Okay, suppose if I calculate wavelength by noting this data, I want to calculate phi here corresponding to the 54 volt and theta here. So this phi I am going to calculate it as 180 minus 55 divided by 2. So therefore, sorry, this is 50 only, 50 degree. So therefore, this becomes what? 50 degree, sorry. Okay. So there will be a strong peak of intensity corresponding to 54 volt and scattering angle is 50. Okay. So 50 here. So this becomes 130 by 2, then 65 degree. Suppose if I take all these values, phi 65 and interplanar spacing 0.91 angstrom, and if I substitute in this equation, so Bragg's law of diffraction, so in that condition, suppose if I substitute, so what I am going to get? 2 into 0.91 into 10 raised to minus 10, or else if you take in angstrom, but angstrom is there, it is. So I have converted 0.91 into 10 raised to minus 10 d value into sine 65 is equal to, suppose if I calculate for first order, where n is nothing but what? That is first order 1, 2, 3, 4, like this first order, second order, third order, so like that. So first order if I take 1 into lambda, so therefore if I simplify this, I am going to get, suppose if I simplify this, lambda value I am going to get is 1.65 angstrom. So once if you look at this value experimentally, what Division and Germer calculated while explaining about or confirming about wave nature of electron, so that is they found lambda is equal to 1.65 angstrom. And remember, this they calculated for the corresponding accelerating potential. This is the wavelength, so or else this is the wavelength associated with the electrons when they are accelerated to a potential of 54 volt, corresponding to the scattering angle is 50 degree. So since according to the Bragg's law of diffraction for the water nickel crystal, so then 2d sin phi equal to n lambda. So if you calculate, d is interplanar spacing of the nickel and it is calculated 0.91 angstrom, it is given here. And then next phi is called glancing angle, so lambda is nothing but wavelength. So therefore, suppose if I calculate that wavelength of the scattered electrons, so then this will be the value I am getting. So lambda is 1.65 angstrom. And once if you look at that value, as well as if I take the theoretical value calculated by de Broglie, so de Broglie theoretically calculated wavelength of electrons, that is lambda is equal to 12.27 by root V, corresponding to the V is equal to 54 volt if I take, then lambda I am getting is 1.66 angstrom. So suppose if you compare the de Broglie theoretical value and Division and Germer's experimental value, so there will be an almost all close agreement will be there. There is a close agreement is there, yes or no? So there is a close agreement between the theoretical value observed by de Broglie as well as the experimental value calculated by Division and Germer. So therefore, definitely this experiment will supports the de Broglie's hypothesis for the wave nature of the electrons. Is it clear? So after completion of this, next we shall switch on to the numericals. So very important chapter, I told you, but this chapter is mainly a theoretical topic. So but also we found some equations. So that is energy of a photon E is equal to h nu, and then we found about Einstein's photoelectric equation. So I think what are the mathematical equations you are getting in this chapter means, first equation, that is E is equal to h nu. We can also write this as hc by lambda. Is it right? So next, this is the one equation, energy of a photon, and from Einstein's photoelectric equation we got K max is equal to h nu minus phi naught. So this equation can also be written as half mv max square is equal to h nu minus phi naught. Why I am telling all these equation? Because they are very important for the what? Numericals. And before this we found another one equation, that is K max is equal to EV naught. So corresponding to this topic potential, we found that there is a maximum number of electrons get scattered. So it means this EV naught is nothing but electrostatic potential energy associated with the electron corresponding to the potential VO, and this they are going to lose. Okay, so this they are going to lose, and this will cause to gain the maximum kinetic energy for the electron under what potential? Under stopic potential. So because under stopic potential the complete electrons get repelled from the collector plate, thereby the photoelectric current becomes 0. So K max is equal to EV naught and E is equal to h nu, and this is Einstein's photoelectric equation. Further we can modify this equation and even see K max is equal to EV naught. So therefore we can write this also as what? EV naught is equal to h nu minus phi naught. And what is the equation for work function? So work function phi naught is equal to h nu naught, where nu naught is threshold frequency. So next, further we have de Broglie's hypothesis, that is de Broglie's wavelength associated with material particle is given by lambda equal to h by mv. This is for both material as well as radiation particles. Lambda is equal to h by mv, and further this wavelength is modified as in terms of kinetic energy also we can express this. Okay, kinetic energy also we can express this equation, that is lambda is equal to h divided by root of 2 mkv. Okay, so I think you might be remembered. And at last we calculated for subatomic particles, this will be given by lambda equal to 12.27 angstrom by 54 voltage, 54, okay, root 54. So like this, root V, this is root V, not 54, root V. Okay, so like this there are some mathematical equations here. Based on this we can work out we shall work out the numericals. So that I am going to explain right now. So we shall go through the numericals one by one. So first, see, listen here. An electron moves from zero potential to the place where the potential is 45.5 volt. So it means the electrons are moving from where to where? Moving. Problem number 1. Problem number 1. Electrons are moving from zero potential, so 0 volt to 45.5 volt. Then calculate what is the velocity of the electron. So we need to calculate velocity of the electrons. So question is very simple. So what is the velocity of the electrons? For this they have given data. Charge of electron 1.6 into 10 power minus 19 coulomb, and mass they have given 9.1 into 10 power minus 31 kg. Okay, see here, there are electrons, and these electrons are moving from 0 volt condition to 45.5 voltage. It means they are accelerated from 0 to, at a potential of 0 to 45.5 volt. Under this condition, what is the velocity associated with the electrons? So here they have given the data, charge of the electron and mass of the electron. So tell me which equation I supposed to use. See here, electrons are accelerating in this potential. So accelerating in this potential means we know that the kinetic energy of the electron will be equal to what? EV. So kinetic energy of the electrons is equal to EV. So it's not necessary that they have not mentioned here it is a stopic potential or anything. So in general, kinetic energy is equal to EV. So here what they are asking, velocity. So we can write the expression of kinetic energy here, half mv square equal to E into V. So I will write this is a small v. Okay, small v I will write. Okay, thereby velocity. Is it clear? So what I want to calculate? This v only. So therefore v is equal to, or v square is equal to 2EV, yes or no, divided by m. So this is under root. So what is the equation we are getting here is velocity of the electrons is equal to square root of 2EV by m. So E is given, m is given, V value is 45.5 volt. If you substitute, so velocity V is equal to square root of 2 into 1.6 into 10 power minus 19 into 45.5. Okay, so divided by m. What is the mass of the electron? That is given 9.1 into 10 power minus 31. Suppose if you simplify this square root and all, so you are getting the answer is 4 into 10 raised to 6 meter per second. The answer you are supposed to get 4 into 10 raised to 6 meter per second. I think you are going to do it. So perform the mathematics here. Just if you simplify, you will get the result 4 into 10 power 6 meter per second. So next, this is EV. Next, second one, second problem. Second problem pertaining to this one only, but there is the same equation we are going to use here. The maximum velocity of the electron emitted is given here. So they gave here the electrons are ejected with a maximum velocity, and that maximum velocity they have given as 1.8 into 10 raised to 6 meter per second, and here they are given the E by m ratio, that is charge to mass ratio of the electron, they have given as 1.8 into 10 power 11 coulomb per kg, and they are asking you to find V naught. They are asking you to find V naught, capital V naught. So what is capital V naught? Stopping potential. Very simple problem it is also. Stopping potential. Stopping potential. See here, there are electrons ejected from certain surface and they are moving with the maximum velocity of 1.8 into 10 raised to 6 meter per second, and E by m of the electron they have given. Find VO. We know that maximum velocity means kinetic energy is maximum. K max is equal to EVO. Therefore, half mv max. Yes or no? Half mv max is equal to EVO. That is nothing but stopping potential. So therefore, what is VO becomes here? So VO is equal to 1 by 2 m by E of, that is mv max by E. So this implies VO is equal to mv max by 2E. Suppose if you substitute m, that is E by m they have given, I think. So m by E is there. Here it is m by E, but E by m they have given. So just if you take that value, and this is V max they have given. If you substitute, you will get stopping potential 9 volt. So I think you are getting, yes, 9 volt is the stopping potential you are getting. So these type of problems are important for the some 2 marks or 3 mark. So in 2 marks, 3 marks, they will put some simple questions. So at that time it will be helpful to you. So next problem. So next, third problem. In my next session I will take further problems. Let us take another one problem here. The third one. A photon of energy 8 electron volt. There is a photon whose energy is, they have given 8 electron volt. Fine. is incident on a metal surface of threshold frequency. Means there is a metal surface whose threshold frequency will be 1.6 into 10 raised to 15 hertz. So it means this is the energy of the photon. I am going to incident on a metal surface whose threshold frequency is this much. Then what is the kinetic energy of the electrons? So they are asking you what should be the kinetic energy associated with the ejected electrons when you illuminate this much energy on a surface of a metal having this much work function. So it is the kinetic energy. So how to find this? For this they have given the data. H is equal to 6.625 into 10 raised to minus 34 joules second. With this much they are asking you to find what is the, see here energy is h nu, threshold frequency, asking you kinetic energy. So E is equal to h nu, okay. So if I incident this much energy of the radiation, we know that to escape the electrons from the surface of a metal, they need certain minimum energy, and that energy we called as what? That energy we called as what? That is phi naught, work function. H nu I am incidenting, but they have certain fixed value of h nu naught. Obviously h nu is more than h nu naught here. Okay, thereby what happens? The electrons are ejected. So electrons are ejected means they have some they are having the kinetic energy. So here is an equation which connects h nu naught kinetic energy. Which equation? Einstein's photoelectric equation, yes or no? K is equal to h nu minus h nu naught. Obviously question is very direct here. They are asking you to directly K. H nu is 8 electron volt. I can use, what about h nu naught? Only nu naught is known. So first we shall find h nu naught. So what is h nu naught? So here h nu naught is equal to phi naught. This implies, or else phi naught is equal to, first we shall find this one, 6.625 10 power minus 34. What is nu naught? 1.6 into 10 power 15. So what it becomes? Phi naught is equal to, suppose if you simplify this, listen here, it is the energy term here, and this energy term is nothing but h nu naught, but h nu is expressed in electron volt. But what is the unit of energy? That is joule. SI unit of energy is joule, but here it is expressed in electron volt. So therefore, if I want to express this complete value in terms of electron volt, if I take this one, I am getting joules. ನೀವು ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದರೆ ನಿಮಗೆ ವ್ಯಾಲ್ಯೂ ಏನು ಬರುತ್ತೆ? ಜೌಲ್ನಲ್ಲಿ ಬರುತ್ತೆ, ಬಟ್ ಜೌಲ್ನಲ್ಲಿ ಬರಬಾರ್ದು. ಸೊ ಯಾಕಂದರೆ ಒಂದು ಡಾಟಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ನಲ್ಲಿದೆ, ಅಥವಾ ನೀವು ಈ ಡಾಟಾನಾದರೂ ಎಸ್ ಐ ಸಿಸ್ಟಮಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ರಿ, ಆರ್ ಎಲ್ಸ್ ಇದಿಷ್ಟು ಡಾಟಾನಾದರೂ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟಿಗೆ ತೊಗೊಂಡು ಬರ್ರಿ. ಸೊ ಜನರಲಿ ಇದನ್ನು ಮಾಡಬೇಕಾದ್ರೆ, ಸೊ ವಾಟ್ ಈಸ್ ದ ಈಕ್ವೇಷನ್? ವಿ ನೋ ದಟ್ 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joule. So 1 electron volt ಅಂದರೆ 1.6 into 10 power minus 19 joules of energy ಗೆ ಈಕ್ವಲ್ ಇರುತ್ತೆ. So therefore this much of joules energy is equal to how many electron volt ಅಂದ್ರೆ obviously ಏನು ಮಾಡ್ತೀರಿ? divided by 1.6 ಮಾಡ್ತೀರಿ. So therefore divide here 1.6 into 10 raised to minus 19. So then what is the value of phi naught becomes? So phi naught value, the value of phi naught becomes is 6 electron volt. ನೀವು ಇದನ್ನು ಮಾಡಿದಾಗ 6 electron volt ಅಂತ ಬರುತ್ತೆ. ಸೊ ನೀವು ಅದನ್ನು ಒಂದು ಸತಿ ಮಾಡ್ಕೋಬೇಕು. Is it clear? So phi naught equal to 6 eV. So since what happens here? H nu is 8 electron volt minus 6 electron volt. Therefore kinetic energy is 2 electron volt. Okay. So this is about the thing. Is it clear? Okay. So well students, with these 3 numericals I will conclude my today's class. In my next class I would like to continue the further numericals. Okay. Thank you.